guys, this is Mrs. Foy, and this is a little screencast about molarity. What is molarity? And molarity is one way to measure the concentration of a solution. There's several different ways that we can do that, but molarity is one way. And to think about the concentration of a solution, think about making a lemonade mix, right? So if you add a lot of that powdered lemonade mix, then you can make your lemonade very concentrated. And if you added less of the mix, then you would make it more dilute. So here's kind of a cartoon about a very concentrated solution of lemonade, solution number 2, and a very dilute solution of lemonade in picture number 1. And these little dots would represent the molecules of the lemonade solution, or what we call the solute. So if you were making lemonade from a mix, that the solute would be the lemonade mix, the solvent would be the water, and the solution is the solute plus the solvent, and the lemonade itself would be the solution. So a solution is actually a homogeneous mixture. You may remember that from earlier in the year. So a concentrated solution is going to have more molecules or more moles of solute than a dilute solution. If you have the same liquid in both of these containers, clearly I have less of the solute over here, and so this would be a more dilute solution and this would be a more concentrated solution. So there's a bunch of different ways that I could measure how much solute is in there. I could actually count the number. I wouldn't count them, but I could calculate the number of atoms or molecules. I could count the number of moles, or I could have that the number of the amount of the solute, I could do it in grams. So one of the ways that we measure concentration is by this word molarity. Molarity is the moles of the solute divided by the volume of the solution in liters. And it is represented by a capital M. Now students get confused because that capital M is actually representing a double unit. The N is the moles of solution and divided by the volume of the the volume of the solution underneath, and it's abbreviated as an M. Just remember, every time you see a capital M, that is actually a double unit. That's actually representing moles divided by volume. So if you are given the amount of the solute in grams, then you would need to convert using the molar mass to get the moles of the solute. And if you were giving the solution in milliliters, then you need to convert that there are 100 milliliters in a liter, and you would need to convert to liters. So it's got to be moles of solute divided by liters of solution. So here's a question that I wanted to ask you. Which of these acids is going to be more concentrated? A 2 molar solution of hydrochloric acid or a 6 molar solution of hydrochloric acid? And we can see that the 2 molar solution is going to be 2 moles of hydrogen chloride divided by 1 liter of hydrogen chloride solution. And the 6 molar hydrochloric acid is going to be 6 moles of the solute HCl divided by 1 liter. So this one is going to be much more concentrated solution of hydrochloric acid. So guys, we have already in class been going back and forth between these two concepts of converting back and forth from a mole. So we know how to go back and forth from mass to moles. We use the molar mass, and we can flip it in our conversions to get rid of the unit that we don't want. We also know how to go back and forth between the number of particles. We use Avogadro's number, 6.02 times 10 to the 23. And I can put either 1 mole over Avogadro's number or Avogadro's number over 1 mole, depending on which unit I want to get rid of in my factor labeling problem. Right now we haven't learned about this gas at STP, but you'll see that later. But what I'm going to talk about today is we can now go use molarity as another destination on our mole map. So 1 mole, or the number of moles of solute divided by 1 liter, or I can flip it and say 1 liter of solution divided by the number of moles. I can flip those molarities depending upon which unit I want to get rid of. So I have 3 problems that I'm going to show you, and then you're going to practice some in class. So here's molarity problem number 1. If you had 4 grams of sodium hydroxide in 500 milliliters of solution, what is the molarity? So I want the molarity. Remember, this is a double unit. Molarity means moles per liter. So if you want a double unit, you start with a double unit. And you would say, well, Mrs. Foy, there's no double unit. Well, you have to make one. So I put the 4 grams on the top and the volume on the bottom, which in this case is 500 milliliters. So the first thing I'm doing in this conversion, you can see that I'm converting milliliters to liters. So my milliliters cancel and I get liters on the bottom, which is good because I want liters on the bottom because molarity is moles per liter. And now I'm going to convert my grams of sodium hydroxide into moles of sodium hydroxide. And I got this from the periodic table, right? So the molar mass of sodium hydroxide is 40 grams per mole. And I just flipped it so the grams go on the bottom, so my grams cancel here and here. And then I am left with moles on the top. So I'm left with moles here and liters on the bottom. And so my answer is 0.2 moles per liter, or 0.2 molar, 0.2 molar. Remember, I only have 1 sig fig here. So problem number 2, how many grams of sugar are in a 6.5 molar solution of sugar, C6H12O6, we're using glucose as our sugar formula, if you have 675 milliliters of it. So the first thing I tell my students is, remember when you see that capital M, that is moles per liter. Go ahead and write it down. 6.5 moles per liter is the same thing as 6.5 capital M. That is a double unit. That will help you remember that is a double unit. And then the problem also says I have 675 milliliters of it. So remember, if you want a single unit answer, which I do because I want grams, you start with a single unit. This is a single unit. This is a double unit. So I'm going to write down 675. So the first thing I have to do is I have to convert to liters, so my milliliters cancel and I have liters. And then this is my molarity, 6.5 moles per liter. Do you see that I do not have to flip this equivalence because the liters are already diagonal from each other and they cancel? So I have moles at the top, but my question says how many grams, so then I have to convert using the molar mass of glucose. In 1 mole of C6H12O6, which is glucose, the molar mass is 180.18 grams. And so my moles cancel, and I get to grams, and I do the math, and I get 790.5 grams. 790.5 grams looks like I only have 2 sig figs, so then I put that in scientific notation with 2 sig figs, and that's my answer. Finally, mole problem number 3. How many milliliters of solution is in 25 grams of a 7.8 molar solution of sodium hydroxide? Remember, if I have 7.8 capital M, that means 7.8 moles per liter. That's a double unit. So I want a single unit answer. The question says how many milliliters. So I want milliliters as my final answer. So if I want a single unit, I start with the single unit. So I'm going to write down 25 grams of sodium hydroxide. First thing I have to do is, sodium chloride. So the first thing I have to do is convert to moles. So I find the molar mass of sodium chloride and I cancel out my grams, and now I'm in moles. Now I can use my molarity, which is moles per liter, but guys, I have to flip it. I have to flip it, which I can do in an equivalence like this. I can flip it and just put the 7.8 on the bottom. The 7.8 stays with the moles, and then I can flip it so that the moles cancel with the 1 mole of sodium hydroxide here. The moles cancel. Now I'm in liters, and the question says I want milliliters, so I have to convert to milliliters here. And so I have canceled out everything but milliliters, so I know I'm done with my problem. I do the math, I end up with 54.84, and then because I only have 2 sig figs, I can see here that I put this in scientific notation with sig figs, 5.5 times 10 to the 1 milliliters of sodium chloride solution needed. So you may have to rewind and watch this video again. We're going to practice these in class. I will see you in class. Good luck.